Hey everyone, Chef Tom here, and I'd like to welcome you to episode 2 of my 65816 ATX project, which I lovingly call Project Neon Sunrise. This is where we're going to start putting our serial interface in place. Today's goals are pretty straightforward. Today we want to get our W65C51N chip into the breadboard and wired into the computer. To do that, we're going to have to update our memory map, because the 65 series processors use memory mapped I/O, so we'll have to pick a space in the memory map for where the serial controller will live. Figure out the chip select logic that we want to use to access that part of the memory and block it out to just the serial controller. And then use that information to actually wire the 6551 into the breadboard. So let's head over to my whiteboard and figure all that out. So let's start with figuring out how we want to wire these things together. We have our 6502 and our 6551 here on the whiteboard, and the obvious first step is to wire the data bus together. That's easy. Now we need to figure out where we want to put it. Via 0 is at 6000, so let's put this at 6800 for now. We may have to redesign the memory map later. But the important thing there is that allows us to use the same first 5 bits. So 01101 as the high end of our address bus. And we can go through that pretty easily. We need a chip select low. A15 and A12 would both be 0. So if we OR those together, we'll have a time when chip select low is always true. And then we need a chip select high, which, since we have the low, we can invert that to a high and pass the other lines, which will all be high, to a 4-address NAND gate, and that will only ever be true in that scenario. That would give us a pretty straightforward chip select logic, and something we could incorporate into a GLA or PLA further down the line. We'll start with a 74LS32 quad 2-input OR gate. This will allow us to do our chip select low logic from lines A12 and A15. We already have a 74LS00 NAND gate for chip logic for the VIA, so we're going to use another gate from that to use as an inverter. And then the 74LS21 dual 4-input AND gate, which will take the inverted chip select 1 line plus all the other address lines and output our chip select high. This will put the 6551 starting at hex 6800 and give us access to all the data in registers by accessing 6800 through 68OF. So, as usual, we're going to build on the lower board. We've got a brand new 6551, so let's straighten the pins on that guy. And we'll drop them in here around pin 40 just to leave ourselves some space for control logic. Alright, so we'll start with our 74S32. I do have some mix and match chips here. I'll order all the right ones going forward. This is just what I happen to have here. I'll order some LS32s. We're going to replicate the LS00 chip that's up here, the NAND gate. Down here, when we design updates to the board, we'll incorporate that right into the chip up top. And unfortunately, I dug around for a few minutes and I can't find any quad input NAND gates, so temporarily going to have to make do with a standard AND gate, and we'll just tie our inputs together. That'll work just fine for prototyping here. Obviously, each of these is going to need to be tied to power and to ground. It's not the prettiest wiring I've ever done, but it'll get the job done for prototyping. Next, we'll get some DuPont wires out. Get jumpers. And we'll wire up the logic to these gates. We'll start with taking A11 and a 15. Indicate 1, and that is our CS low, which will go into pin 3. I'll put to pin 3 of our 6551. That'll also go into, well, to our NAND gate, which we're going to use as an inverter. And that will give us the inverted signal to output to the first gate of our AND chip. Now remember, I don't have a quad AND chip ready to go right now, so we're going to wire in all 4 of these separately. And that will give us our chip select high for the 6551. So eventually I'll write that into some sort of PLA or GLA, but that is much further down the line. Okay, next we'll take our data lines. D0 is on 18, so 15, 16, 17, 18. And then just follows the next 8 pins. Alright, data bus is wired up. We will need access to the register select pins. And RS0 would come from A0, because that way we can address it as 6800. And RS1 to A14. I think that's the only control lines we need. Let me double check that. And we need access to the reset line. Which, don't. Which I don't have as on the breadboard connection. So that is another thing we have to add to the list of things to do in the version 3 prototype. So let's add a output from the breadboard connection. That pin there. Or we can use the bottom of the resistor, I guess. Get the soldering gun heated up. So while my soldering iron is heating up, I bought a couple of these D-sub breakout headers for testing. They came as a 2-pack, so I got 2. Probably would have gotten 2 anyway. I like to buy extras of everything. So when we go to wire this up first, I'll probably just come off of the breadboard into this to start with, as I'm trying to figure out what is needed and isn't needed for what we need to get done. But so I do have these ready to go. I don't know if we'll get to them in this video, just because I wasn't expecting to do any soldering in this video, so this is going to take a little longer than I planned. Again, not the prettiest job, but for some prototyping, this should do just fine. So let's put the board back together. Make sure we line up our power and ground right. Everything else will line up after that. Oh, it's camped underneath. Okay, this is now reset, which we will put all the way out here on the end. We'll probably add it to this first group when we make the next version of the board. We'll add it down here with all other control lines. And reset on the 6551 is on pin 4, so we'll jump that back over to here. And I think that's where I'm going to call it, because I need to do a little more reading on the 6551. I spent way too much time this week. What pin? Which one of you popped out? I spent a lot more time trying to figure out the address decoding logic this week, so I think I'm going to call building here while I read up on the 6551 and what I need to do to wire it to the 9-pin D-sub. So let's head back to the computer to wrap this up. So between the extra time it took to develop the logic and the extra soldering I had to do on the board to get the reset line out, I decided to break here. Also, I need the 232 line drivers, which I didn't realize I needed. I thought the 6551 could just be hooked straight into a RS232 DE9 port. I need to get some voltage drivers, so those have been ordered and they're on their way, and so we'll finish this in the next video. And hopefully I'll have some more updates for you by then too. Bye.